Hey folks, in this video we're going to be talking about algebra, but with units. It's some science maths. Let's talk about it. We got two main objectives, and I would like you to be able to manage units when you're performing addition and subtraction, and also manage them sweet units when you're performing multiplication and divisions. So let's talk about addition and subtraction first. It's a little bit less complicated. When you're doing these, addition and subtraction, in order to add or subtract measurements, they have to have the same units. So if I wanted to do 15 centimeters plus 27 centimeters, that's cool. I'll get 42 centimeters. Those units work together. They're the same thing. If I do 55 liters minus 11 liters, that's also cool. I'm going to get a cool answer of 44 liters because those units are the same thing. But measurements with mismatched units, those don't work out so well. We can't just easily add or subtract those. Like if I did 15 centimeters plus 27 miles, what's my answer supposed to look like? Is it going to be in miles? Is it going to be in centimeters? I don't know. Really what I should do here is convert these units, because they're both measurements of length. I should convert them so that they're the same unit, probably those centimeters, because yeah, the imperial system sucks. We're going to convert them, and then we can do our addition, but not the current way they are. And this is really wiggity whack, like 55 years minus 11 kilograms. I don't know about that. Those are like totally different units, so that's not going to work at all. And so this is kind of similar to algebra. Like if you do 5x minus 3x, that's going to give you a real cool 2x. But if you try and do like 5x minus 3y, well, that's not as easy of a situation. We're probably going to need to do some sort of conversion and change y into x, sort of like this situation up here. So addition and subtraction with units, we always want to make sure that our units are the same if we're adding and subtracting, and that may sometimes entail doing some conversions. If we're doing multiplication and division, things can get a little bit spicier. This is pretty similar to algebra, so let's lead off with some algebra examples just to make sure we know our algebra good. If I do like 2x times 3x, well, that's going to give me an answer of 6x squared. And the way I'm going to look at this is, first I'm just going to look at these actual numbers, and I'm going to say, all right, well, 2 times 3 is 6. That was easy. And if I look at, then I'm going to look at my units, or the variables that go with them. So x, if I have x times x, well, that's the same as x squared, because when I put a little square, that's like, hey, this number times itself. So, yeah, x times x. Cool. Let's look at another example. If I've got like 4x cubed divided by 2x, why don't you pause the video and see if you can solve that bad boy? Well, the answer I came up with was 2x squared. And so again, I just looked at the numbers and I was like, yo, 4 divided by 2, that's 2, no problem. And then I looked at the units and I was like, all right, well, I got x cubed divided by x. That should give me x squared. And I could break those apart to make it a little bit maybe more logical. X cubed is the same as x times x times x. So when I divide it by x, one of those is going to go away. Now I've got x times x, and we know that's the same as x cubed. Last algebra example, what if I do 5y divided by 3x? Pause the video, think about that, dude. Well, my answer is going to be 2.67 y over x. And so what I'm going to do is the same old thing. I'm going to look at my numbers first and go, all right, well, 5 divided by 3, that gives me my 2.67. And in terms of the units, well, if I've got y divided by x, those units don't cancel each other out. We're just going to have both of them together. And so now we've got y over x. Y divided by x. Cool beans. We got to keep both of our units or variables present in that case. Well, we're going to do basically the same thing when we're dealing with units. We're going to treat them like y or x. So an example here, if I've got 5 centimeters times 2 centimeters, why don't you pause the video and think about what would the appropriate answer for that be? Well, I'm going to look at my numbers first. So numbers. Oh, well, let's get the answer first. The answer is 10 centimeters squared. And so to get that, I'm going to look at my numbers first and be like, all right, 5 times 2, that gives me 10. And then I'm going to think, all right, centimeters times centimeters are my units. That's centimeters squared. Centimeters times centimeters is centimeters squared. All right, well, let's look at another problem. Why don't you pause the video and give this bad boy a whack? Nifty. Well, what's the answer to this? It's 0.75 grams per centimeters cubed. Yes, indeed. Let's look through that. So the numbers, pretty straightforward. 3 divided by 4 is going to give me that 0.75. I should really write that as 3.0 and 4.0 to be good about significant digits. Bad boy wine grad. I'm a bad boy. Anyway, the units here, I've got grams, and I'm dividing that by centimeters cubed. Well, those aren't going to cancel each other out. So kind of like the situation we have up here, we're just going to keep both of them together, and we're going to put the grams in the numerator and the centimeters cubed, which we divided by, in the denominator of my unit. Well, let's look at one more example. Why don't you pause the video and See if you can whack at this one. All right, well, you pause the video. Let's talk about it. So here we've got 1.8 centimeters squared as our answer. And that comes from, first of all, the numbers. 9 divided by 5 gives me the 1.8. And then the centimeters cubed, well, that's going to be giving me centimeters squared when we divide it by centimeters. And it's similar to this situation up here. Centimeters cubed is the same thing as centimeters times centimeters times centimeters. And when we divide that by centimeters, go away, Jake face. When we divide that by centimeters, it's going to be the same thing as canceling one of these out, leaving us with centimeters times centimeters, or centimeters squared. Sweet stuff. Well, that's the end of this video. I hope you feel good about using using algebra with units and doing math with science. All right, cool. Ta-ta. Have a great rest of your life.